Hi, I'm Seema, Assistant Professor, Department of ECE, SERENVIT. Here I'm explaining one of the computer networks lab program, Stop and Wait Protocol. The aim of the experiment is implementation of Stop and Wait Protocol and Sliding Window Protocol. Here we are explaining only Stop and Wait Protocol. Stop and Wait Protocol is a flow control protocol and it is one of the versions of Sliding Window Protocol. So sliding window protocol with the sliding window size of 1 will be called as Stop and Wait Protocol, which means Stop and Wait Protocol will have the sender and receiver window size of 1. So now to explain up with Stop and Wait Protocol, considering a sender and a receiver, if you have 3 frames to be sent to the receiver, the first frame will be sent to the receiver with the sequence number 0. And once this data is received by the receiver will acknowledge it back by this acknowledgement with the number 1. So for the sequence number 0, you will be acknowledged with 1, which means that the receiver has received the frame with sequence number 0 and now it is ready to receive the frame with sequence number 1. So once acknowledgement with number 1 is reaching the sender understands that the frame which is being sent is already received and now it gets ready to send the next frame. So now frame 2 is being sent with the sequence number 1. And once the receiver receives the sequence number 1 frame, it will now send the acknowledgement. And this acknowledgement will have the number 0, telling that the frame with sequence number 1 is already been received and it is now ready to receive the sequence number 0. And once the acknowledgement 0 is received by the sender, it gets ready to send the next frame. So the next frame will have the sequence number 0. And once it receives, again, it will send the acknowledgement 1. So this is how the flow goes on. So it is a flow control protocol where the flow is controlled by acknowledgement. So you are acknowledging for each and every data of size 1. So here you have to remember one thing. So when the data is sent with a sequence number. And once the data is received, you will be receiving an acknowledgement. So the receiver receives the frame and the sender receives the acknowledgement. And the numbers here will always be zeros and ones. And now here, let us understand 2 more special cases of stop and wait protocol. So here, the first case is what happens if the data is lost. And the next one is what happens when the acknowledgement is lost. So here, let us take an example that you are sending frame 1 with sequence number 0 and in between the network, the data is lost, which means the receiver never receives the data. In that case, what happens? When the sender sends frame 1, it will start up a timer. Once the timer starts, it will wait for the acknowledgement. So it will wait for a certain amount of time, and if the acknowledgement is not received in that instant of time, it is understood that it is timeout. So it will wait for an amount of time, and if it is not receiving any acknowledgement, it times out. Once it is timed out, it understands that the data has never been received by the receiver and I have to now resend the same frame. So it will again send the same frame, and if it is reached to the receiver will send the acknowledgement. And the next case is what happens if the data is received by the receiver and the acknowledgement is lost. So here you have a timer, as we have already told. You have a timer here and the timer will be on when the data is sent. So once the data is sent and the acknowledgement is also sent by the receiver, and the acknowledgement will never reach the sender, and you will have a timeout. So if the acknowledgement doesn't reach on time, the timer will time out. And once the timer is time out, the sender will understand that the data itself is lost because it has no idea about reaching the data to the receiver and the receiver sending the acknowledgement. So what does the sender do? It resends the frame. So once the data is resent, the receiver receives the data, but now since already the receiver has received the first frame with sequence number 0, it will not take this data in. Instead, it will discard this data, but it will send the acknowledgement to the sender. So what the receiver understands? The receiver understands that the acknowledgement which have been sent previously has not been received by the sender, so it is resending the frame. So it understands, it discards the frame, and it will send the acknowledgement. So these are the three cases. And here, let us start writing the program. So I would like to write the program in documents folder inside C program. So the command what I use to get the screen where I start writing the program is gedit. Once you use this command, you will have a screen displayed for us where we will be writing the program. And here I would like to introduce what all cases we are considering for stop and wait protocol. We are considering three cases. The first case is when the data is lost. The second case is when the acknowledgement is lost. And the third case onwards, you will have the regular data and acknowledgement flow. So these three cases have been considered. And for that, we have made up the initial settings. What are the initial settings? We have taken a variable frame. We have taken a variable frame where what happens when you put up the data as 0 for frame, it means that there is no frame in the network. And if you have the data here as 1, it means that you have a frame in the network. So when does this variable used? So when you send a frame from the sender towards the receiver, the frame will be made as 1, which means that you have a frame in the network. So having a frame in the network will have frame with 1. And if there is no frame in the network, it has been made 0. And the next variable is ACK, acknowledgement. So if the receiver sends an acknowledgement, then there will be an acknowledgement in the network that will be reflected as acknowledgement is equal to 1. And if there is no acknowledgement, then it is made as 0. And here you have the next variable ready. So if the sender is ready to send the frame, you will have ready as 1. That is, the sender is ready to send the frames. And if it is not ready, that means if the sender is busy, then it will be made as 0. The next one is the timer. So timer is a very important variable here to calculate the time for the transmission of data and the reception of the acknowledgement. So if the timer is on, you have timer to be 0, and if the timer expires, that is timeout, is reflected as timer is equal to 1. Along with that, we have some more variables used, that is the sequence number and the acknowledgement number, which is very important here to know the sequence. That is, to have the flow control, you need to have the sequence number as well as the acknowledgement number. And along with that, as I told you, there are three cases to be considered. That is, data is lost, acknowledgement is lost, and there is a normal flow. So you have the maximum cases to be defined as 3. And since the first case we are considering it as the lost data, we are considering a variable as lost frame. So the first frame what you will be sending will be the lost frame, and the second case is losing the acknowledgement, that is lost acknowledgement is equal to 2. The second case, the second frame what you send will be losing its acknowledgement. So with this inputs, let us start how the program is written. So initially in the main program, we will ask how many frames you want to send towards the receiver. So here you have to give minimum of 3 because we have taken minimum 3 cases to understand this protocol. So you give minimum of 3. So if you give more than 3, then what happens? From the fourth frame, there won't be any losing of data or losing of frame. So it will be the normal execution. So you can give any value greater than or equal to 3 to understand stop and wait protocol. So once you have been given with the input, it will enter the while loop where it will start sending the data. So it sends the data here. So it is calling a function which is called as sender. So in this program, we will have three functions defined. One is the sender, the another one is sleep, the other one is receiver. So sender is a function which performs all the operations of the sender. Receiver is a function which performs all the operation performed by the receiver. Sleep is a function which is used for counting the time. That is, it acts as a timer for us. So sleep of 2, that means we are defining certain amount of time as the timer for sending the data and receiving the acknowledgement. So initially what we do is we will be sending the data. So you will call the sender program where the sender transmits the data, and we will turn on the timer. And now what we have to do, we have to now cross upon all the stages. So the first case is the lost frame. So you have to now check whether the frame number is equal to lost frame. Yes, since the initial value of frame number is 1, which means we are starting to transmit the data from frame number 1. So since frame number 1 is equal to lost frame, that is, this is the first case what we have to consider. What it does is it will make frame is equal to 0. That means frame is equal to 0 means there is no frame in the network. So you will stop the data in the network itself, and you will clear the lost frame variable, and you will put a message telling that frame has been lost. So the first case is being initiated here by not sending the data. Okay, so we transmit the data, the sender transmits the data, but we will tell that there is no frame in the network, so that the receiver will not receive any of the frames, and we will put a message that the frame is lost. And once the sender has sent the data, but we have not made that data to reach the receiver. Now it is the receiver part which has to take care, or which will be now eagerly waiting for our frame. So now what it does, it again, the receiver again waits for the data, and since it doesn't receive any of the data, it will keep waiting. And here what we are doing is we are taking up the receiver part, and we will again wait for some time. And if the frame number is equal to lost frame, we are now taking up the second case. So what happens if the data is being received and the acknowledgement is lost? So what we are doing here is, here we are considering the case of a receiver, the second case, that is the frame is being received, but you are not sending, you are not putting out the acknowledgement to reach the sender. So you are putting out the acknowledgement. After putting out the acknowledgement, you are making acknowledgement as 0, telling that you have sent the acknowledgement, but you have made that acknowledgement to drop out in the network itself, so that the sender will not receive any of the acknowledgement. And you put out the message telling that the acknowledgement for the particular frame has been lost. So now obviously when the acknowledgement is not being received and acknowledgement is equal to 0, what we have to do is we have to tell that the timer has been expired. Okay, so this is the main program where you are sending the data, but you are losing that in the network. That is the first case. The second case is you are receiving the data and you are transmitting the acknowledgement, and you are losing that acknowledgement in the network. And the third statement is you are not receiving the acknowledgement. In that case, there will be timeout. So these are the three cases you have to consider in the main program. And now coming for the sender function. So what does the sender function do? So now let us see in all the three cases, what is the operation performed by the sender? The sender has to send the frame when the sender is ready. So you have to check whether the sender is ready. If it is ready, you have to send a frame by putting proper sequence number. And you have to tell that you are busy sending the frame. by putting frame is equal to 1 and ready is equal to 0. So it means that you have a data frame in the network. So frame is equal to 1 represents that you have a frame in the network. So when the sender is ready, you put out the frame with the sequence number by making frame as 1 and switching on the timer. Now, what is the next operation? The next operation is if you don't receive the acknowledgement on time, so which means you have to now check the timer. So if timer is 1, it means that timer expired. So what the sender has to do when the timer expires, when the timer expires, you have to resend the same frame with the same sequence number. So when the timer expires, you have to resend the frame by putting frame as 1 and again restarting the timer. That is the second operation your sender has to do. And the third one is if the data is been properly received by the receiver and the receiver puts out the acknowledgement, the work what it has to do is, in this case, for example, so the receiver receives the data and it will send the acknowledgement. So once it sends the acknowledgement, the sender has to receive that acknowledgement and put out the message telling that acknowledgement for a particular frame has been received. Okay, so once the acknowledgement is received, what it has to do? It has to now take up the number of the acknowledgement and make that number as the sequence number, telling that the receiver is now ready to receive the particular sequence numbered frame. So that is what has been done here. So sequence number will be changed and acknowledgement, since it has been received, you have to make acknowledgement as 0, telling that acknowledgement is also already been received. And after that, what it has to do, since we are bothered only about the major 3 cases, if the number of frames are more than 3, you have to keep the normal flow of data. So the normal flow has to be considered. That is being taken care in the next loop. So the sender has 4 major operations. Once the first one is if it is ready, you have to send the frame. The second one is if the timer expires, you have to resend the frame. The third one is if the acknowledgement is reaching the sender, it has to receive it, and by receiving the proper acknowledgement number, it has to set the next sequence number for the frame, and at the last you have to note how many frames are left out for the transmission. The next function here is the receiver. So this function will explain us what is the work of the receiver. So the major work of the receiver is to receive the frame. So when it has to receive the frame, it has to receive only when frame is equal to 1. That means when you have a frame in the network, you have to receive the data. If there is no frame, it is useless waiting for the frame. So only when you have a frame in the network, you have to receive the data. So when frame is equal to 1, you have to receive the data, and that too, what data has to be received should be very carefully observed here. See, in this case, when sequence number is 0, you have to send the acknowledgement 1. And you have the acknowledgement 1. When you have acknowledgement of 1, it means that you are waiting for sequence number 1. So which means acknowledgement number what you previously had should be same as that of the receiving sequence number. So that is being taken as a condition here. If the previous acknowledgement number is equal to the present sequence number, then only you have to receive that particular data. Okay, so if not, which means that in this case, what is happening, we have the acknowledgement of 0, and here you are receiving the sequence with number 1, where there is a mismatch, which means that this data what we are receiving is the data resent. So you have to not consider this data, but you have to discard it. So which means when the acknowledgement number and the sequence number are not matching, it means that the frame is been resent, or the frame is a duplicate, and you have to discard it, and you have to again resend the previous acknowledgement number. So the only operation the receiver has to do is it has to receive the data frame when you have a frame in the network by properly noting down the acknowledgement number and the sequence number. So this is all about the receiver function. Now let us see the execution. So as usual, you have to use the same Linux command, that is gcc-o name of the program, program name.c. Once it is done, if you have any errors or warnings, that will be displayed here. And we have a warning. Why? Because we have not defined the function sleep. But sleep is a function which is already defined implicitly in our software. So we have not explicitly explained the sleep function. So let us discard this, and we will go for executing with the next Linux command /stop_wait. It will now ask how many frames you want to send. So we are interested in sending 4 data frames. So now let us see how the execution goes. So when the sender has 4 frames to be sent, frame number 1 is being sent with a sequence number 0. And since the data is lost here, the timer will be expired. So that is what is being given here. Frame 1 is sent with sequence number 0, but frame 1 is lost. So the timer expires. So when the timer expires, what we have to do? Again, we have to resend the same frame with the same sequence number 0. So frame 1 with sequence number 0 is been resent. And now in this case, you will be receiving the data, and once the data is received, you will send the acknowledgement. So the data is received and the acknowledgement with acknowledgement number 1 is sent, which means that the first frame is received, you are waiting for the second frame. So now once the acknowledgement for the first frame is received, frame 2 is sent with the sequence number 1. So in this case, frame 2 is been sent with sequence number 1. So the receiver will receive the frame, and after receiving the frame, it will send an acknowledgement. But here what we have done, we have lost the frame, or lost the acknowledgement of this frame. So since the acknowledgement is lost, the timer times out and the acknowledgement is been lost. So what we have to do, we have to again resend the frame with the same sequence number. And here what happens, when the second frame is sent with the same sequence number 1, and 1 is not equal to 0, the receiver understands that the frame is been resent. So this is the frame which is been previously sent. So what it does, it tells that frame 2 is resent with the sequence number 1, but frame 2 is a duplicate, and I'm discarding it, but I'm sending the acknowledgement number 0. And now the sender will receive the acknowledgement. After that, it has to now send the third frame. So since from the third frame we have the casual movement of the data and acknowledgement, so frame 3 is sent with sequence number 0, and the receiver receives the third frame and the acknowledgement will be sent. And here again, the acknowledgement for frame 3 is received, and you are now sending the fourth frame. And once the fourth frame is sent, the receiver receives the fourth frame and it now sends the acknowledgement. And since our case has got only 4 frames to be sent, the timer expires because we have only 4 frames and there are no more frames to be transmitted from the sender. This is all about the stop and wait protocol. So here in stop and wait protocol, you have only 1 frame to be sent at a time, and till you get the acknowledgement for that particular frame, the next data is not sent. So that is stop and wait protocol. Stop and wait till the acknowledgement for the sent data is being received. So this is a special case of sliding window protocol with a sliding window size of 1. Thank you.